All right, guys. So something I get asked about relatively frequently is improper fractions. So an improper fraction is something where we have, well, a fraction is something with a numerator, right, which is the number on top, and the denominator, the thing down below here. Now, a fraction, let's make a proper fraction, 3/4. Okay, boom, no problem. A fraction's actually not that scary by itself. Okay, it just means 3 divided by 4, top divided by bottom. You can also think of it in terms of a percentage, like 3/4. If you do figure out what that is, either through long division or calculator or something similar, or through memory, right? Because 1/4 is a quarter. A quarter is 25 cents, 25 over 100. Anyway, you know that you have a percentage here, potentially, right? If that's what you're measuring as. So fractions we use really all the time, all right, which is great. But when you have improper fractions, like let's just go ahead and say 4/3. Let's throw that other one on its head. It's an imbalanced or an unbalanced fraction. That's what I like to call it because it's top heavy. And anything that's top heavy is very, very likely to topple over. And so that's why I call it an improper fraction. Hey, it just helps me think about it the right way. And so usually you're not allowed to leave these fractions this way with the top ready to fall over. They want you to put it into whole values. Now, for small little denominators like this, or even somewhat larger ones up to like 8, maybe 10, you can easily visualize them. So you can say, okay, well, I have 4. Well, that's supposed to be like that, and like that, and like that. So I've got a pie that's cut into 3 pieces. 1, 2, 3, but I'm not here to the numerator yet. I've got another pie. Zoop, zoop, zoop. 1, 2, 3, 4. And so you visualize it. And you say, well, I have a whole pie, and I have 1 out of 1, 2, 3. 3. So 1 plus a third is 1 and a third, which is exactly the same as this little guy here. Right now, you can always go backwards. This is a step that most people miss. You take the whole value here, the integer, 1 times the denominator because it tells you how many parts it was. 1 times 3 equals 3/3. 3 over 3 is 1, so there's no difference. 3/3 and 1/3 is 4/3. So our thinking checks out that 1 and 1/3 is actually 4 3/3. So we've changed an improper fraction into a mixed number, into a whole number and a proper fraction. Okay, so that's all right, but a lot of times they're not as simple as that. Let's see. Let's choose like 28 over 3. Okay, so if you know your math facts and you kind of think, okay, what number do I get really close to multiplied by 3? And I know that would be 27 is really close. You can take 3 times what equals 27. Now you can think up to that too. You can always say like 1, 2, 3, 1, 2, 3, 1, 2, 3, all the way up. But 28 is a pretty big number here. So what we're going to do instead, you can also do long division, by the way. But what we're going to do instead is I'm going to assume I know that math fact, and I'm going to say that I know that 9 sections, right? 9 3 out of 3s will fit into 28. Okay, so I've got 9 and what? Okay, well, 9 times 3 is 27. So I have 27/3 wrapped up into this 9. So it's 9 and 28 minus 27 is a third. Okay. So That's not bad. That's equal to 9 1/3. It's a mixed number. So I have a whole number here and a proper fraction. That's okay. You could also represent this as, depending on how you're asked to represent it, you could say 9 with, a remainder of 1/3 or something similar. That's okay. We can talk more about long division if that's a big demand, but otherwise, this is a pretty solid approach. Let's just see if we've got it down by doing some more examples. Now, we're sticking with numerators that are single digit. Doesn't have to be that way, but I totally recommend that you go and do long division if you're trying to resolve improper fractions where the numerator is more than 1 through, let's just say 10, right? Anyway, let me pull one out. Let's see. How about, let's say 17/5. So 17/5. It's top heavy. It's going to topple over. We got to fix that puppy before it does. So I know that 5 goes into 17. How many times? Well, let's see if I can think this one through. It goes in one time, sure, but there's plenty left over because I know that 17 minus 5 is 12. That's way too much. 2 of 5s is 10. So it definitely goes in there. 17 minus 10, though, is 7. And I know I can fit another 5 in there. 3 5s would be 15. 17 minus 15 is 2. I don't know. Could I fit 4 5s in there? Well, 4 times 5 is what? 20. That's way too much. So let's go backwards. 5 times 3 is 15. So I know I'm going to have 15/5, and I have a remainder of 2/5. That's 15 plus 2 is 17/5. Remember, you add across these common denominators here, right? They're exactly the same denominators. They're in the same family, if you will. And so, boom, we can say, all right, well, 15/5, I knew that was 1, 2, 3 5s that fit into that. Can you break this up into groups or visualize them in some other way? Sure. 1, 2, 3, 4, 5. Oh, that doesn't look very good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Boom. 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 Okay, so that's 3 wholes. That's 3 and 2/5. Or if you want to write it as a mixed number, there you go. You have a whole number here, an integer value, and the proper fraction. And your teacher's going to be really happy about that. Okay. This, by the way, would just be 1, 2. All right. So you can't circle that. You'd have to have 3 other dots in there to make that another whole value. They look like cookies. That's pretty yummy. All right. So let's talk about this again. If you're not sure about your math facts, which really just multiplication facts, totally encourage you to memorize those up to at least 12, right? Like 12 times 12 is 144, etc. Those are really, really useful. But let's just say that you had a somewhat small number like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I really feel like I missed a number there. 4, 8, 12, 16, 17. No, I didn't. Does not matter how I draw these out as long as I can circle some. So I'm just gonna connect dots. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have 1, 2, 3 holes. And what do I have here left over? I have 2. And that's my 2/5. Okay, 3 and 2/5. Hopefully this is helpful. I can definitely go into more detail if needed, but it's definitely going to be a start.